Hi folks, today we're going to talk about the surface area of a cylinder. So we need to talk about some definitions first. A cylinder is a three-dimensional figure with two parallel congruent, that's not written in there, so you need to write that in there, two parallel congruent circular bases and a curved lateral surface that connects the bases. So I want you to think about a cylinder and the definition of a polyhedron. A polyhedron is a three-dimensional object with at least four polygonal faces. So I want you to think about a cylinder. Is a cylinder a polyhedron? No, it's not. It's made up of circular bases. Circles are not polygons. And that curved lateral surface. So this is not a polyhedron, but it is a three-dimensional figure. The lateral surface of a cylinder is the curved surface that connects the two bases. So what I have here is a net of a cylinder. So it's kind of hard to see, it's kind of hard to fit all into the screen, but I do have the net of a cylinder. And so in order to put it all together, I'm going to kind of roll this up. And then we have a circular base on the top and a circular base on the bottom. Okay, so this is our cylinder. Now the lateral face is this, and it curves. So we had to kind of roll it up so that it would connect the two bases. So this is the lateral surface. It's that curved surface that connects the two bases. But whenever you unroll it and you create the net, that lateral surface ends up becoming what shape? It ends up becoming a rectangle. So keep that in mind for later on, that this lateral surface can unfold, uncurl, and uncurve, and it can become a rectangle. So that is your lateral surface of the cylinder. Now, if you look down at the bottom, we have this little dashed segment here, and we have a dashed segment here. And we've got kind of things coming out that indicates that we're labeling it the same thing. This is the same term, but we need to call it something. So typically, whenever you have something like this, and it's at a right angle to the base, and it's connecting the bases, we'd say this is the altitude. It's measuring the height. But here, this is not necessarily the altitude, because the altitude is always at a right angle to the base, and this is most definitely not a right angle. So we need a new term for this. Well, what this ends up being is the axis of a cylinder. And I want you to think about taking a cylinder and kind of on its axis giving it a good spin. That's something that will help you connect the idea of an axis with a cylinder, because axis is usually something that you spin either a globe on or a graph or something like that. So the axis of a cylinder is the segment with endpoints at the center of the bases. So remember, those bases are always going to be circular in nature. Here, this axis of the cylinder is also the altitude. It's measuring the height. It's at a right angle to both of the bases, and it's measuring that distance between them. So not only is this an axis of a cylinder, this is also an altitude. But here, this is not. An altitude would be something that would be out here. So this distance, this is an altitude. But this and this are both axes of symmetry. Oh, it's not of symmetry, I'm sorry, of cylinders. My brain is thinking about algebra. So the axis of what we call a right cylinder, which would be something like this, because the axis of the cylinder is at a right angle to the bases. So this is called a right cylinder. The axis of a right cylinder is always perpendicular to its bases, to those circles. Now this is not a right cylinder. Our axis of the cylinder is not at a right angle here. We call this an oblique cylinder. So I want you to imagine it's kind of leaning to the side. If you've ever played with a slinky and you've put it on the ground or on the table or something, and then taken the top and just kind of moved it a little bit, this almost looks like a slanted slinky. So this is called an oblique cylinder, and the axis of an oblique cylinder is not perpendicular to its base. So either the axis of the cylinder is perpendicular or it's not, meaning it's a right cylinder or it's an oblique cylinder. The axis of a right cylinder is the same length as its height because it is also the altitude. So just keep that in mind, that there is a connection there for a right cylinder between the height, the altitude, and the axis of the cylinder. So we have that label. These two right here kind of pointing to that curved surface, so that's the lateral surface. That's the one that kind of unfolds. So it kind of unfolds to become that rectangle. And then this and this, those are bases. Same thing over here. This and this, these are bases. So on the bottom it asks, after looking at the figures above, is the axis of the cylinder always the altitude? Why or why not? I'll give you a moment to think about it, maybe answer. Pause your video and answer. The answer is no. It's not always the altitude. It is here, but it is not here, because the altitude is always perpendicular to the bases. Always. So in a right cylinder, the axis of the cylinder is the altitude. It's perpendicular to the bases. In an oblique cylinder, the altitude is not the axis of the cylinder, because the axis of the cylinder is not perpendicular to the bases. The altitude is this distance right here. Okay, so let's go on to our second page. We want to talk about the formulas for the lateral area and the surface area of right cylinders. So for right now, we're kind of putting aside the oblique cylinder idea, and we're simply talking about right cylinders. So you'll see a right cylinder perfectly formed, and then here you'll kind of see the unfolded version or the net of this right cylinder. So it kind of looks like mine. The bases are in different places, but that's perfectly fine. We just need a base on top and a base on bottom. So the lateral area. The lateral area is just this curved surface. Okay? It's not the bases, not the area of the bases, it's just that curved surface around. Well, whenever you unfold the cylinder and you look at the net, we're just talking about this. This is the lateral area. These are the bases. This is a base. We're not including that, we're just talking about this. And it's nice because the formula for a shape like this, a rectangle, is a width times a length. Well, I want you to think to your cylinder. We've got a radius here. This distance right here is the what? That distance is the height of the cylinder. So think about where it would be here. That distance would be right here. That's the height. So that's good. That's one part of our area of this rectangle. The other part is this, though. This right here. And so I need to find the length of that long side. And in order to do that, it might be helpful to look at the net, because whenever you take your net and you fold it up, the length of that side will wrap all the way around the figure, and it's capped off by this circle, right? So the length all the way around is the distance all the way around this circle. And what is that name? What's the name of the distance that goes all the way around the circle? It's called the circumference. And the formula for the circumference is 2 times pi times the radius. So the lateral area, the area of this curved surface unrolled into a rectangle, is the perimeter of the base times the height. Well, that would be the circumference of the base, 2 pi r, times the height, h. So this is the formula for the lateral area of a cylinder. Now let's talk about the surface area. The formula for the surface area of a prism is the perimeter of the base times the height of the figure plus 2 times the area of the base. Now we already have this right here. This is the lateral area. But let's put the pieces in the correct places. So the surface area is the lateral area, 2 times pi times r times the height, plus 2 times the area of the base. Well, remember the base is a circle. So down here and up here, the base is a circle. So the formula for the area of the base is the formula for the area of a circle, pi r squared. So I have plus 2 times pi times r squared. This is my formula for the surface area of a cylinder. Now, of course, these older formulas, this one and this one, for the lateral area and the total surface area of a prism would work just fine, but because we have circular bases, we can be a little bit more specific with our formulas. So in example 1 says find the lateral area and the surface area of the right cylinder. So it's nice to know that this is a right cylinder. It's not oblique. The lateral area can be found using this formula. L equals 2 times pi times the radius times the height. So we just need to figure out all the pieces. 2 is a coefficient. Pi is a coefficient. The radius here is half the distance all the way across. So if all the way across the distance is 16 inches, then the radius's distance would be half of that, 8 inches. And then finally, we want to multiply by the height of the figure itself, and the height of the cylinder is this distance right here, and that's 10 inches. So the lateral area is 2 times 8, which is 16, times 10, which is 160, times pi, and we're going to leave it as 160 pi, measuring in inches squared, because it is an area. So there's the lateral area of the cylinder. And now I want to find the surface area, the total surface area. Now I've got 3 formulas to pick from. I have kind of the more basic formula. I have the basic formula with this replaced with the lateral surface area. And then I have everything kind of written out in detail. So it doesn't matter which one you use. I'm going to go ahead and use this, this bottom one right here. Kind of a combination of the bottom one and this one, because I'm just going to take my lateral area from the problem and I'm just going to insert it right here. So lateral area plus 2 pi r squared will give me my surface area. So our lateral area was 160 pi plus 2 pi times the radius squared. Well, in this problem, we decided that the radius was 8 inches. So I'm going to take 8 and I'm going to square it. So 160 pi plus 8 squared, which is 64. And 64 times 2 is 128 times pi. And when I add those two together, because they are like terms, they're both in terms of pi, 160 pi plus 128 pi is 288 pi. And we're measuring in inches squared, because surface area is a type of area. And I do realize that this could have been put under here. And that's my mistake. All right, so let's move on to our last page of the notes. Our last page of the notes is a little odd. It asks for the surface area of the composite figure. So I'm not being asked for the surface area and the lateral area. I need the total surface area of this figure. Now, this figure is made up of multiple three-dimensional figures. It's made up of kind of like a box down here, so a prism, a rectangular prism, and then it's made up of a cylinder. But the key is, I don't want any overlapping pieces, and I only want the area of the surfaces that are on the outside. So I want you to pause your video and come up with some kind of plan that combines the surface area or the lateral area of your rectangular prism and your cylinder. So I want you to pause your video, come up with some kind of plan, and write it down. So hopefully you were able to come up with a plan. Your plan should probably include the surface area of the prism. So the surface area of the rectangular prism. And we should be adding to it the surface area up here. Well, there's a few different ways that you can add the surface area of the cylinder, but not overlap. And the issue is this base right here. This base right here is part of the cylinder, but it's also part of the area of the top of the rectangular prism. So it's kind of overlapping right here, and I don't want either circle. So you can either take the surface area of the rectangular prism and add to it the surface area of the cylinder, and then subtract out the circle at the bottom of the cylinder and the circle at the top of the box. So 2 areas of the circle. That would be acceptable. You could also take the surface area of the prism and you could add to it just the lateral area of the cylinder. Not adding or subtracting another circle, because if you did the area of the prism, the full surface area of the prism, and then the lateral area of the cylinder, well, this circle right here that's part of the prism could just be moved up a little bit and it could be the top circle. So the area of this bottom circle and this top circle are the same. So if you just have this area of the bottom circle, it could be removed and replaced on the very top. So either of these plans are acceptable. There's a few other variations that would be okay, but let's stick with these. It seems like these are more simplified than up here, so that's what I'm going to go ahead and use. The surface area of the prism is the perimeter of the base times the height plus 2 times the area of the base, and I'm going to add to it the lateral area of the cylinder, and the lateral area of the cylinder is 2 times pi times the radius times the height. So let's put in all the pieces. I'm going to say that this is the base right here of my rectangular prism. The perimeter of that base is 9 plus 4 plus 9 plus 4. So 9 plus 4 is 13, and if I double that, I get 26. Times the height of the prism, that's 5. Plus 2 times the area of the base. Well, the base is a rectangle, and the area would be 9 times 4, which is 36. So this is my surface area of the prism, and I'm going to add to it 2 times pi times the radius of the cylinder, which is 2 centimeters, times the height of the cylinder, which is 3 centimeters. So I have all of those pieces together. So using PEMDAS inside of my big group, I have multiplication to be 130. Multiplication, 2 times 36 is 72. I have multiplication, 2 times 2 is 4, times 3 is 12 with the pi. And then I combine my two like terms to get 202 plus 12 pi centimeters squared. So that's the surface area of this composite figure. And if you were to follow this plan or one of your plans that gives the same thing, then you would end up with the same answer. So let's look at our last problem. It also is a composite figure. We need to find the surface area, and I want you to understand what this is. So it's a triangular prism, but then the cylinder right here has been removed from it. And so I want you to know that anything that looks like a hole in your figure is a hole. Like there's no, if you will, there's no caps on the end of the cylinder. There's no bases or anything like that. You're taking out the cylinder. Now I want to be clear. When you take out the cylinder, yes, you are removing the volume. You're removing a large chunk of the inside of that triangular prism. But what you are removing in volume, you're also creating these walls on the inside. The walls of the cylinder on the inside, which means that you're adding surface to the figure. If you imagine, and it's kind of hard to understand, especially without something to look at in front of you. If you imagine this figure and you're painting it. Well, of course, you would paint the outside. You'd paint this rectangle, that rectangle, that rectangle. You would paint the triangles, and then you would take out these circles, right? Because those are holes. And then you would also have to paint the inside. So you would paint the inside of that tube, the inside of that cylinder. So there's a couple different versions of a plan that you could come up with, but I want you to try and write something down. So pause your video and try and come up with a plan of how you're going to create the surface area of this composite figure. So hopefully you were able to come up with a plan. If you weren't, it's okay. I think it's a good idea to start out with the surface area of the triangular prism. So the surface area of the prism, triangular prism, we'll start out with that. And from there, we should probably remove the two circles because those are kind of open holes. So we're going to remove the area of the two circles. And there are two of them, I'm sorry. So it's minus 2 areas. And then in addition to that, we also need to kind of paint the inside of the tube. So we have this extra surface on the inside that's the inside of a cylinder. Well, if you think about a cylinder, here's my net for a cylinder. If you remove the bases, so remove the base, remove the base. If you remove the bases, then this is the tube. This is the inside of what it is that you're painting. And so would this be the full surface area or the lateral area of the cylinder? It would just be the lateral area. So you're going to add to it the lateral area of the cylinder. So again, there's a lot of different plans that could happen, but this is kind of the basis for it. So the surface area of the triangular prism, that formula is the perimeter of the base times the height of the prism, plus 2 times the area of the base. You're going to subtract 2 times the area of the circle. And the formula for the area of the circle is pi r squared. And then you're going to add to it the lateral area of the cylinder. And today we talked about the lateral area of the cylinder is 2 times pi times r times the height. So we have a lot of pieces here. A lot of pieces. Let's start out with this piece right here, this 2 centimeters, that's the radius. So I'm going to go insert the radius everywhere that I have the r. So I have 2 times pi times r squared, r is 2, plus 2 times pi times r, which is 2, times the height of that cylinder. So what's the height of that cylinder? Well, that cylinder, you go from edge to edge, this right here, that's the height. Well, what is that distance? It's kind of the same distance over here. So that height of the cylinder is 9 centimeters. So we have that piece. Now let's try and work on this. So the area, so the perimeter of our triangle is 6 centimeters plus 10 centimeters plus 8 centimeters. So 6 and 10 and 8 added together give me 24 times the height of that prism, which is 9 centimeters. And we're going to add to it 2 bases. And that base is a triangle, which is a little strange because we don't know much about that triangle except for the side length. So I'm going to redraw it out here. This is 6, this is 8, this is 10. It would be really helpful if we knew if this was a right triangle or not. And so I'm going to be thinking about Pythagorean triples because I have all of my side lengths. And I see that 6 and 8 and 10 are all divisible by 2. So this is really 2 times 3. This is really 2 times 4. This is really 2 times 5. Well, hopefully you remember that the most basic Pythagorean triple is a 3, 4, 5. So that means that this is a right triangle, which is wonderful because that means that now when you're finding the area of the base is 1/2 times the base of the triangle, so maybe 6 centimeters, times the height of the triangle, so maybe 8 centimeters. Remember that the base and the height have to be at the right angle to each other. So the area of the base is half of 6, which is 3, times 8, which is 24. And now you can multiply all the pieces together. So 24 times 9 is 216. 2 times 24 is 48. 2 squared is 4, and 4 times 2 is 8 pi. 2 times 2 is 4, times 9 is 36 pi. So now I combine the like terms. 216 plus 48 is 264. And then negative 8 pi plus 36 pi would be a positive 28 pi. And I'm going to put these together and measure in centimeters squared, and this is the total surface area of this composite figure.